Very good morning to all of you. This is third video for the revision of the unit polynomial. And here in this video I am going to consider the multiple choice question with only one right answer. So first I have, if the product of two zeros of the polynomial fx is equal to 2x cube plus 6x square minus 4x plus 9 is 3, then its third zero is, here it is given the product of two zeros. Let us consider the zeros are alpha, beta and gamma since it is cubic polynomial. So the product of its 0, it is alpha into beta into gamma, it is equal to minus d by a, that is in this situation minus 9 by 2. Alpha into beta, if we consider, it is equal to 3 as it is given here in the question. So 3 into gamma, it is equal to minus 9 by 2. Therefore gamma is equal to minus 3 by 2. Similar to this, the option B, it is having minus 3 by 2, so it is right answer. Moving to the next question, if the polynomial fx is equal to ax cube plus bx minus c is divisible by another polynomial gx equal to x square plus bx plus c. So using the division lemma here, if we use dividend is equal to divisor into quotient plus remainder, since gx divide fx in this situation, so remainder should be equal to 0, and the qx, the quotient, I have considered as a linear polynomial. Then only the quadratic polynomial into linear polynomial will give a cubic polynomial. So if we consider dx plus e as the quotient, find the product of gx and qx in that situation and then compare the coefficient. In that situation, if we will compare it, then that is gx equal to x square plus bx plus c when it is multiplied to qx equal to dx plus e. Then comparing the coefficient, we will have e equal to minus 1, which leads us to a into b equal to 1 in this situation. So option A is right here. Moving to the next question, if one root of the polynomial fx equal to 5x square plus 13x plus k is the reciprocal of the other, then the value of k is, in this situation we are supposed to find the value of k, and it is given one root is reciprocal of the other. Let us consider the one root as alpha, so another root will be 1 by alpha, and use the formula product of zeros alpha into 1 by alpha. We will get from here as c by a for the quadratic polynomial, so it is k by 5, so k is equal to 5. Similar to this, option B is right, B is having 5. Now next question we have, if alpha, beta and gamma are the 0 of the polynomial fx equal to ax cube plus bx square plus cx plus d, then find 1 by alpha plus 1 by beta plus 1 by gamma. If we are going to simplify this, in LCM we will, after taking the LCM of the denominator, we will have alpha into beta into gamma, and in numerator we will have alpha into beta plus beta into gamma plus gamma into alpha. So using the formula as sum of the product of zeros taken 2 at a time for a cubic polynomial and the product of zeros of the cubic polynomial, we will have c by a divided by minus d by a. So a and a will cancel, so we are left with minus c by d. So option C is right here in this question. Moving to the next question, if alpha, beta and gamma are the 0 of the polynomial fx equal to ax cube plus bx square plus cx plus d, then find alpha square plus beta square plus gamma square. Using the identity a plus b plus c whole square, it is equal to a square plus b square plus c square plus 2ab plus 2bc plus 2ca. Using the similar identity, we will use here for alpha square plus beta square plus gamma square, it is equal to alpha plus beta plus gamma whole square minus 2 in bracket alpha plus beta into alpha plus beta plus beta into gamma plus gamma into alpha bracket close. Now putting the values using the formula for the cubic polynomial, alpha plus beta plus gamma, that is sum of its 0, it is equal to b by a, and product of its zeros taken 2 at a time, it is equal to c by a. So sum of its 0 minus b by a whole square will give us b square by a square, and product of its zeros taken 2 at a time, we have c by a. So here in this situation minus 2 into c by a. After taking the LCM, in LCM denominator we will have a square, and in numerator we will have b square minus 2ac. So similar to this, option D is right here, that is b square minus 2ac divided by a square. Try to simplify this faster. Now moving to the next set of questions, here we have the number of the polynomial having zeros minus 2 and 5. That is, we are supposed to find the total number of polynomials having zeros minus 2 and 5. Then, since we know that if we consider the quadratic polynomial, that is, it has the at most 2 zeros, then in that situation also the general formula for finding the quadratic polynomial, it is k in bracket x square minus sum of its zeros into x plus product of zeros, where k is having any real values. So depending on the value of k, it can have any number of polynomials. So the right answer is D, more than 3. That is, more than that we will have in this situation. Then next question, if one of the zero of the quadratic polynomial k minus 1 x square plus kx plus 1 is minus 3, then the value of k is, here it is already given that 1 0 of the quadratic polynomial, it is minus 3. So if we are going to put the value of minus 3 in place of x, we will have after simplification 9k minus 9 minus 3k plus 1 is equal to 0. Then 6k is equal to 8. Therefore k is equal to 4 by 3. So the right answer is A, option A, that is 4 by 3. Next question, the zeros of the quadratic polynomial x square plus 99x plus 127 are. In this situation all the terms are positive, that is the first term, that coefficient of x square, it is also positive, coefficient of x, it is also positive, and constant term is also positive. Then in this situation both the zeros must be negative, that is both negative is the right answer, that is option B is the right answer. Moving to the next set of questions, here we have given that 2 of the 0 of the cubic polynomial ax cube plus bx square plus cx plus d are zeros. The third zero is 2 of the polynomial, it is already given equal to 0. Using the formula for the sum of zeros of the cubic polynomial alpha plus beta plus gamma, we have minus b by a, and alpha plus beta, if we consider, it is already given sum of two zeros as 0. So 0 plus gamma, it is equal to minus b by a. So in this situation option A is right, that is minus b by a. Moving to the next question. If 1 0 of the quadratic polynomial x square plus 3x plus k is 2, then the value of k is it is given already, 1 0 is 2. Put the value of x as 2 in this case. So we have 4 plus 6 plus k, it is equal to 0, that is k is equal to minus 10. So option B is the right answer. Next question we have, if the 0 of the quadratic polynomial ax square plus bx plus c not equal to 0 are equal, that is the zeros are equal, then in this situation c and a have the opposite sign, no, it is false. C and b have opposite signs, this is also false. C and a have the same sign, yes, in this situation we will have to consider C and A as the same sign, this is the right answer. And C and B have the same sign, no, this is also false. So right answer is C. If one of the 0 of the quadratic polynomial x square plus ax plus b is negative of the other, then surely in this situation, read the question carefully and observe it. If one of the 0 of the quadratic polynomial of the form x square plus ax plus b is the negative of the other, that is if one is alpha, another is minus alpha, then surely in this situation we must have no linear term, that is option A has no linear term and constant term is negative. This option is right. Thank you for today.